from today, we start Module 3, Recursive Algorithms. So this is a very important topic, very basic. I think all of you have the experience using recursive algorithms, but this time, in this module, we will study, in a pretty complete way. Yeah. All right, our first part A, Introduction to Recursive Algorithms. Part 8.1, First View of Recursive Algorithms. All right. So let's look at our first question. Why recursive thinking is important in problem solving. At the beginning, so for a person who does not have a lot of experience, usually he or she would not use recursive thinking. Yeah, because usually based on our intuition, we like to use straightforward way of thinking, not recursive way. Recursive way is not that straightforward. It is a special way. You need to have some training to get used to it. Otherwise, you may not get used to it. Recursive thinking. Yeah. All right. Here, let's discuss these two different ways. The first way, non-recursive way. Second way, recursive way. So we compare these two ways and look at their differences. All right. So some problems can be solved both non-recursively and recursively. Large number of problems we can solve in two different ways. When you have that situation, which way you should choose, right? Recursive way or non-recursive way? It depends on some important considerations. Sometimes non-recursive way is better, and sometimes recursive way is better. So we need to understand those two different situations. Okay, all right. First, we like to look at the advantage part of the recursive way. It has some big advantage. So what is the big advantage? So this is the big advantage. Power of recursion. It is very powerful. Power of recursion. So that's its biggest advantage. Yeah. All right. Some relatively hard problems can only, parenthesis, I will explain this parenthesis, why I put this only in parenthesis, right? So a lot of explanation on it. Can only be solved by recursion. Some relatively hard problems. Yeah. Because based on people's impression, different people have different views on hard problems, right? For someone, a hard problem, but for another person, probably relatively easy problem, right? So here we just talk about the general, relatively hard problems. We have such examples. Later you will see. Can only be solved. Why? I put this parenthesis only. Yeah. Because based on our textbook, there is one statement, one sentence. It says that every problem that can be solved by recursion can also be solved by iterative method. Iterative, non-recursive way. Could be, typically iterative way. So non-recursive way. So that's the, statement in the textbook. Yeah. But in the real world situation, some problems, if you try to use non-recursive, extremely hard. You do not even know how to do it. Okay? It happens frequently. Later, we will see one example. You will get this situation. So for that reason, because there is some argument about that, so I put that parenthesis. So it's arguably, meaning, because someone may argue about that. So that's why I put a parenthesis. Yeah. At least the author of our textbook, based on his view, he could argue about this sentence. All right. So then let me compare recursion way, non-recursion way. So first way we call iterative method. The second way we call the recursive method. For the comparison, less resource, harder implementation, relatively harder comparing with the recursive way. Less resource. It consumes relatively less resource. Why? I explain later. Recursively, you need to pay a little more resource. Why? I will explain later. Easier implementation. Because when you use the recursion, you can make your algorithm implementation much easier than the iterative way. So you can see big advantage, disadvantage also. All right. Now let me compare resource part. Why? One relatively less resource, another more resource. The reason is simple. How does the programming language implement recursion? Can you think about that? Right? Right now, all the high-level programming languages support recursion, right? Currently, all high-level programming languages support recursion. But internally, those programming languages need to use a special data structure to manage the resource for the recursion. That special data structure is stack. You know stack, right? In 2250 data structure, so that course, you should learn the stack data structure, right? So something like this, okay? So you push your function call in the stack. So for recursion, why the programming language can handle recursion? Internally, it uses the recursion. Okay? When you do the function call, because it relies on another function call of the same function, but you do not have the value, so you need to put in the stack. Then another function call in the stack, right? So finally, at the top, you get a value. Then you can calculate the value, right? Then the value you can use to calculate the next, you're going back, and finally, you find the, complete the final value. But in this case, your stack will be very deep, right? The stack could be very deep. The deep stack consumes a lot of memory space. Okay? Memory space. A lot of memory space. Right? That's the resource cost you need to pay. Okay? Yeah. All right. So that is its big disadvantage. Big disadvantage. It has big advantage. This power thing, it's big advantage than the resource, drawback, big disadvantage. So you need to consider, these two sides in your real world situation. So you should pick the right way to, right method to use. Yeah. All right. Let me use a concrete example to explain different aspects of the recursion. Yeah. All right, our problem number 7. Calculate the factorial. It is a very simple problem. Even we can call it trivial, but here we want to use this simple example to help us understand several basic aspects of recursion. Look at the question first. Given a non-negative integer n, find its factorial. Here, when we start, we consider n greater than 0, non-negative, and it could be 0. Yes, because non-negative, 0 included, right? Yeah. But at this point, can you imagine what is that 0 factorial? What is that? 0. 1, 2, 3. We know how to find the values, right? But for 0 factorial, can you imagine what the correct value it should be? Yeah. Let's see next. Yeah, it's not trivial. It's not trivial. Yeah. All right. Method 1, iterative way. Yeah, everybody can use this iterative way to calculate the factorial. Yeah. Based on the definition of the factorial, n factorial equals product of these consecutive numbers from 1 through n. And 0 factorial equals 1. Can you imagine that? 0 factorial equals 1. Does it make sense? Right? Yeah. We will justify it later when we use method 2, recursive way. We can see it. We can see why it is the correct value. All right, yeah. Implementation. So for the implementation, just a one for loop. You can easily write it out easily, right? Yeah. All right, so I do not write it here. Method 2, recursive way. Yeah. Why we use recursive way? Education purpose here. Yeah. For education purpose, so we learn method 2, recursive way. Idea. Yeah. So the idea, we use recursive way. Here we use a general problem solving approach. Divide and conquer. I think you heard of this divide and conquer terminology. Yeah. It's quite common. Yeah. Even in our, social environment, people use divide and conquer terminology a lot. But here, this is our algorithm environment, algorithm context, or math context. In math, divide and conquer also used a lot. Yeah. So the algorithm, math, a lot of overlap, pretty much 80% overlapping. So we do not try to separate. Yeah. All right. divide and conquer approach. But this is a big topic. This divide and conquer is a big topic. And later we will use the whole module 4. The whole module 4 is used to discuss this big important topic. Okay? So this is a module 4 topic. Okay? Module 4 topic. But here we need to use it a little bit. So we start using it here, divide and conquer idea. All right. Three reasons we use divide and conquer for the recursion implementation. The first one, the problem easier when the size is smaller. Yes, when the size is big, 1 million factorial, is that pretty hard, right? At least computationally it's hard, right? Yeah. But in other computing problems, sorting, when you have 1 million numbers do sorting, you need to do more work, right? Yeah. So usually for a computing problem, when the input size is larger, it is harder to solve. When the input size is smaller, very small, very easy to solve. So that's the simple fact. So we use it. Okay. All right. Number two, when you work on a problem of the current size, you can assume that the problem of a smaller size has been solved. This is the essence of the recursion. You can assume a problem of smaller size has been solved. So that result can be used to compute the value of the current problem size. This view is critical. So this is the critical view. Right? Yeah. This critical view helps us make the problem solving easier. Okay? All right. But there is some gap, so you assume problem with smaller size solved, and the current size, still there is a gap, right? That gap, you need to fix it. Fix it by recursion formula. You need to derive a recursion formula. That formula will be used to fix the gap through a recursion relation. Okay? So you can see these 3 points explain the main reason behind recursive method. So that's simple. All right. So let's work on it. Yeah. N factorial. Now let's view it differently. All right. N factorial, let us use a new function f of n to represent that function for discussion purpose. So we use a new function, represent it. Yeah. All right, after that, we do divide and conquer. We need to divide that problem. So the problem, this big, we want to make it smaller. How to make it smaller? You need to divide somewhere. Here, our way for that division, we chop the last factor, last operand. Let's call it operand. Okay, last operand. Chop it off. Then this part smaller, right? Yep. This part smaller. We represented f of n minus 1. The problem size is reduced from n to n minus 1, smaller. And we can assume we have the solution of that smaller problem. We can assume we have it. Okay? After that, we need to fix the gap. There is a gap. Okay? So the gap, we do multiplication of f of minus 1 with that n value. The part, we just chop it off. Okay? All right. So at the end, we get a recursion formula. F of n equals f of n minus 1 times n. Recursion formula. So with that, we can do recursion implementation. And you know how to do it, right? Yeah, I don't need to do that. You can do it easily. Yeah. Here, we just try to understand the whole structure of recursion. All right, now it is the time to understand why that n factorial equals 0. Yeah. So here we assume n greater than 0. Okay. All right. So now let's look at why n factorial, 0 factorial equals 1. Okay. All right. Let's do this kind of understanding. We change the formula, recursion formula, in a different way to help us see it. So what way do we use? We represent f of n minus 1 equals fraction way f of n over n. That's correct, right? Yeah. Based on our recursion formula, that's correct. Okay? All right. With that, let us plug in n equals 1. How about that? Let's plug in the value n equals 1. Because the right-hand side, when n equals 1, each term makes sense, right? F of n makes sense. Numerator, denominator, and 1 also good. Nothing wrong in the right-hand side fraction. So let's plug in it. F of 0 equals f of 1 over 1. F of 1 equals 1, so the answer is 1. But what is f of 0? Right? What is f of 0? Based on our definition, it is 0 factorial, right? F of 0 is just the 0 factorial. Then we just derive 0 factorial equals 1. There is no problem in our derivation, right? Every step is legal, right? Nothing is wrong. Our logic is perfect here. So the result must be correct. For that reason, now we can comfortably make 0 factorial equals 1. Because if you make that assumption, this recursion formula is perfect. It is perfect. Otherwise, it may have some problem. So now we make it a perfect recursion formula. All right. Yeah. For the material, study material, I give you the reference in our textbook chapter 4, starting from page 131. Yeah. As the conclusion, yeah, it is an interesting way to solve problem. Interesting way. Yeah. Interesting. Usually people use this word interesting. Sometimes maybe positive, sometimes maybe negative, right? Yeah. Here, when we say interesting here, yeah, it's the positive way, interesting. Right? Positive, interesting. So we can also make it, valuable. All right? Not just positive way, strongly positive, valuable, pretty strong, right? So it is a valuable way to solve problems. Why it is valuable? In our next video, 8.2, we will see the power of recursion. Very powerful. So we really need this method. All right, so let's finish our 8.1 video right here.